So we said that because atoms are so small, it's impossible to actually count atoms. So we count the number of atoms by weighing them. Now remember, they're so small that we actually have to use a large number to make it work. So the mole is actually what we're going to use to count our atoms. 1 mole of a natural element will have a mass that's equal to the element's atomic mass. Now, atomic mass is measured in AMU, atomic mass units. Molar mass is going to be calculated or measured in grams. Okay? So atomic mass unit, the mass of one single atom, is so small, it doesn't do us any good. We need to work with grams. Now, in order to work with grams, we need a very large number of atoms to make it work. So 1 mole, which is abbreviated MOL, not much of an abbreviation, but there you go, is going to be equal to Avogadro's number, which is 6.02 times 10 to the 23rd atoms, which is going to be equal to the mass on the periodic table. Instead of measuring it in AMU, we're going to measure it in grams. Okay? So if I looked at this little table here I've got aluminum. 6.02 times 10 to the 23rd atoms is going to be equal to 26.98 grams because aluminum weighs 26.98 grams. Okay? Copper, if I have 1 mole, I have 6.02 times 10 to the 23rd atoms. This time it's going to weigh 63.55 grams because copper is 63.55. Okay? So 1 mole of any element is equal to Avogadro's number, 6.02 times 10 to the 23rd atoms, which is equal to the mass on the periodic table measured in grams, which is also called the molar mass. So here's how we do calculations using those numbers. So aluminum is a metal with a high strength to mass ratio and a high resistance to corrosion. Thus, it is often used for structural purposes. None of that actually matters for my problem. Compute both the number of moles and the number of atoms in a 10-gram sample of aluminum. I'm going to have to do 2 calculations, 1 for moles, 1 for atoms. So let's start with moles. So I've got 10 grams of aluminum. Now, just like I did before with conversions, because I'm starting with grams of aluminum on top, in order to make them go away, I have to put grams of aluminum on the bottom. So this will allow these units to cancel. Instead of grams of aluminum, I want moles of aluminum. Okay? So if I look at my table, I know that 1 mole is equal to the molar mass. So I'm going to put 1 mole. To find my molar mass of aluminum, I look at the periodic table, the big number, 26.982. And those are my grams. Okay? So what I'm going to do, remember, numbers on top I multiply. 10 times 1 is 10. Numbers on bottom, I divide. So 10 divided by 26.982, I get 0.370617. I still want to keep track of significant figures. I started with 3, so I need to keep 3 at the end. 1, 2, 3. I'm going to cut it off there because 6 is higher than 5. I round up. So I've got 0.371 moles of aluminum. Okay? I also need to calculate atoms. So I've got 10 grams of aluminum. Now I can either start with the same number that I was given, or I can start with the moles and change moles to atoms. The truth is, moles to atoms is a little bit simpler, but I'm going to show you this way just so you can kind of see what happens. Okay, so I still need to make grams of aluminum go away. This time I'm changing to atoms of aluminum. Okay, so grams is still the number from the periodic table, which I said was 26.982. And I know that the number from the periodic table is always equal to Avogadro's number. So the number on top is 6.02 times 10 to the 23rd. Okay? Now this is why I could have started with my moles as well. My moles, I had already taken 10 divided by this, so then I would just have to do this top part. If I hadn't already calculated moles, then this is how I would set it up. Okay? Now just like before, numbers on top we multiply. 10 times 6.02 times 10 to the 23rd divided by 26.982. I get 2.231117. I still only have 3 sig figs. 1, 2, 3, cut it off there. Because it's a 1, I leave it alone. So it'll be 2.23. Now that's not all my calculator will say. Depending on the type of calculator I have, it might have a little caret next to it, it might have e to some number, but it's going to be times 10 to the 23rd atoms of aluminum. Okay? My grams went away. I'm left with atoms. It's really important when dealing with atoms that you keep track of your scientific notation. 2.23 atoms is very, very, very different than 2.23 times 10 to the 23rd. That's the difference between somebody owing you $2.23 and $2.23 billion. So make sure you keep track of those. Okay? So let's try one that's a little bit harder. A silicone chip used in an integrated circuit of a microcomputer has a mass of 5.68 milligrams. How many silicon atoms are present in the chip? Now it's almost exactly like the one we'd done before. Almost. The difference is this time my mass isn't in grams, it's in milligrams. I've got 5.68 milligrams of silicon. The problem with milligrams is the number on my periodic table is given to me in grams. So I can't keep milligrams. I need to make milligrams go away. Instead of milligrams, I need grams. Now, hopefully we learned those prefixes in the last chapter. Milli stands for 1,000. Well, it's actually a thousandth. There are 1,000 milligrams in every 1 gram. Now I can stop and do my calculation here, or I can keep going. I'm going to keep going because while I took care of milligrams, I still need to change grams, and I need to change grams into atoms. So in the next step, I need to make grams of silicone go away. They need to go on the bottom because they need to be opposite each other. I want to change to atoms of silicon. Anytime I see grams, I know that that number has to come from the periodic table. If I look on the periodic table, silicon has a mass of 28.086. And I know that the number from the periodic table is always equal to Avogadro's number, 6.02 times 10 to the 23rd. Now when I plug this into my calculator, 5.86, numbers on top I multiply, times 1 stays the same, divided by 1,000. Numbers on top I multiply, so times 6.02 times 10 to the 23rd. Numbers on bottom I divide, so divided by 28.086. I should get 6.18477. I started with 3 significant figures, 1, 2, 3. Because this is a 4 and I only look at the number right next to it, it stays 6.18. This isn't all my calculator should say. It should have a caret or an E, 10 to the 19th. Don't ever forget your exponents. And this is going to be atoms of silicon. Okay? So take a second and try to solve example 3. In example 3, you're doing 2 calculations: the number of moles and the mass. So you're looking for grams, and we're working with atoms. Okay? So to give you a head start, remember we always start with our number given. Okay? And you're going to change atoms into moles. Then we're going to change atoms into grams. Okay, so here's what you should have done. To change it into moles, we need to make atoms go away. So this time atoms needs to be on the bottom. Now the number that always goes by atoms, Avogadro's number, 6.02. I'm changing it to moles. Avogadro's number is always equal to 1 mole. Now when I plug this into my calculator, numbers on top I multiply, numbers on bottom I divide. It's really important that when I enter this into my calculator, I put this value in parentheses. Otherwise, what my calculator is going to do is it's going to divide by 6.02, and it'll equal that out, and then it'll multiply by 10 to the 23rd. So make sure you put this whole thing in parentheses. And what you should get is you should get 8.3056. I started with 1, 2, 3 sig figs. I keep 1, 2, 3 sig figs. Because this is a 5, it rounds up. So 8.31. I should have exponents. So this is times 10 to the -4th moles. And it's going to be of cobalt. Okay? Now for the second conversion, I can either start with this number or I can start with this one. I've shown you how to start here before, so let's go ahead and start here. So I've got 8.31 times 10 to the -4th moles of cobalt. Now I need to make moles go away. So moles need to go on the bottom. I want to change that to grams. So grams go on top. If I look at the periodic table for cobalt, cobalt is 58.933. The number on the periodic table is always equal to 1 mole. Because this is on top, I multiply. When I multiply, I get 0.0489 grams of cobalt. I started with 3 sig figs. I still have 3 sig figs. Okay?